Today I shall be talking about what does NVMe offer, and because there's a bit of detail in the talk, I have got a printed set of notes that you're welcome to take away with you. Several machines have got a suitable slot into which you can plug an NVMe drive, and that the DeskPi Mini, this device, which is the WaveShare Mini I/O board, the Pi Foundation I/O board with a suitable adapter. On all of those boards, RISC OS cannot see the onboard real-time clock, so you have to basically add it. So, you can't see the onboard real-time clock and fan controller because they're on a separate bus that RISC OS doesn't look at. They all use the compute module 4, which can be clocked to 2 gigahertz, as long as you've got some sort of cooling. And you've got just room, and it really is squeezed in, to add the real-time clock and the fan on the header. But Linux can use the onboard real-time clock and fan, which is underneath. An advantage of the Pi Foundation board is that you've got access to the run pin, so you can add a reset push button. You can choose different adapters for the PCIe slot, so you can have different, you can have SATA or you can have NVMe, and the speed control of the fan is better. On the 5-volt fan it tends to be either on or off. The DeskPi has an onboard fan which CPU clock can control. So that's what the WaveShare board, which I'm using to display the slides, that's what it looks like. And you can see that there's a circuit board squeezed in around the edge of it that carries a CJE real-time clock board and an Adafruit fan controller. And underneath is an NVMe drive. Now, storage media have got limitations, and we know that the STFS, the eMMC, 50 megabytes a second is about the most it can do. But unfortunately, all of these interfaces that we've got available to RISC OS are quite limited. Whereas on a desktop machine, you might have a generation 3, 4-lane PCIe card. They're limited to the generation 2 by 1 on the I/O boards, which limits it to 400 megabytes per second, which is the same speed that the SATA medium itself is limited to. And it's also limited by the filing system. So I now have a graph which shows several things, but what it's basically saying is that the RAM filing system maxes out at about here. So however good the filing medium is, it won't beat RAM FS. So there's only a certain amount of headroom we've got to increase storage speeds. Now, Serial Advanced Technology Attachment, SATA, uses a serial interface and can run up to 500 megabytes a second, but that's its peak speed. The non-volatile memory express NVMe has got low latency and some parallelism, and the interface can run up to 3,500 megabytes per second. So it has more potential, but it's the actual interface that limits the speed. So here's a horrible graph full of test figures for SATA and NVMe on RISC OS, and what you can broadly see from this is that the NVMe speeds have approached SATA speeds. So between the two, there isn't very much, particularly in the random read and write, that would make a big difference between the two. SATA is slightly faster for block reads and writes, but you don't really do much of that on RISC OS, only when loading and saving a file. And there's another table for the alternative NVMe, which shows that a couple of drives are a little bit idiosyncratic, so it won't actually work with them. But that's not actually a problem, because they won't supply you with an incompatible drive. But basically the speeds are similar between the two alternatives and exceed SATA speeds if there's a SATA variability. Some of the slower SATA drives, they're already faster than that. So, there is a detailed discussion of the merits of SATA against NVMe. You've got limits from the file core filing system and the performance of RAMFS. Describes how the testing was done and what NVMe looks like to RISC OS over a USB caddy. And then those notes are available online. The conclusion is that NVMe has got the potential to offer RISC OS much better random read-write speed than SATA, but it's still being optimised. It's more compact. As you can see, the desk pie is even smaller than this, and you can buy them in various bits and make your own case, or you can buy them ready-built in the form of the Desk Pi Next from Arnos or the Pyro Cube from RISC Bits. Some drives connect using USB 3, but that doesn't help RISC OS, because RISC OS can't really drive USB 3 at its proper speed. So we get our best result from PCI Express. So, RISC OS NVMe drivers are being released at the show. Now, what I have done on my machine is to split the NVMe drive so that half of it is used for RISC OS and half of it is used for Linux. So that means preparing the NVMe drive with 4 partitions on it, so that Linux can look at 2 of them and RISC OS can look at 2 of them, and they keep out of each other's way. It's extremely complicated to describe how you get the right format, but I'll rattle through it quickly and tell you that there are proper notes of exactly how to do it in detail, again online. So we're probably all familiar with the RISC OS 2-partition solution that has been used for the Pi, where you have a fat partition with all the firmware in and a file core partition with all of the RISC OS files. So what I'm doing is building on that. So if I then go into Linux, I can add 2 more partitions to fill the rest of the drive up, and then they end up in a rather strange order, because the way it works is that they end up with partition 1, then 4, then 2, then 3. So Linux doesn't really like that, so there's a description of how you tweak that around. And you end up with an NVMe drive where you can boot into either RISC OS or Linux. So I could show you that at this stage. So if I hold the button down, it should boot into Linux. And it has. And if I reboot, this time not holding down the button, reboot back into RISC OS. So you've got the best of both worlds. I could have carried on with the presentation in Linux using the PowerPoint slides that I've created, because it will run OpenOffice with no problem. Or I can go back into RISC OS and use Artworks Viewer to do it, which is what I've been doing up until now. Let's I've got no network plugged in, so it will hang around for a little while looking. So what's in the partitions on this NVMe drive? Well, you've got the usual fat partition for the firmware, followed by a file call partition of about half the size of the drive, which embeds in with the fat partition. And then the two partitions I've added in Linux. I then have to tweak the partition table, and Linux allows you to write just the partition table to disk. I've written a little basic program which you can see now is sorted them out into order 1, 2, 3, 4, whereas they were 1, 4, 2, 3. Linux can see both fat partitions, and it can use partition 1 for its boot drive, so that your boot, there's no other storage plugged in apart from the eMMC, which has only got RISC on it. Linux is completely using the NVMe drive to boot from. It makes it easy to switch between the operating systems, and there are detailed instructions on how to prepare the disk. Just at the time I was looking at NVMe, a formatter still wasn't available, but I believe that's being released yesterday, so it should now be in the daily downloads. H-form is in a later version now that will allow NVMe to be selected as a filing system, as well as SDFS, ADFS and SCSI. So you build it yourself. The Compute Module 4 is now seems to be available in reliably, so it's no longer the elusive beast it was. This requires a 5-volt power supply. I find the eMMC version of Compute Module 4 is better because current RISC OS ROMs can't see large SD cards on the CM4 Lite, and that's a bug that hasn't been fixed yet. A dual boot solution is a good idea, and NVMe is the future. You need to think about adding a fan or a heatsink. Now, the WaveShare fan has such a chunky metal base that when you bolt it onto the Compute Module 4, you don't really need to run the fan, but it seems to keep cool enough just with the solid base. But if you're doing particularly intensive stuff, then yes, it does warm up a bit and it's useful to run the fan. The Desktop Mini already has a fan built in. Now, that's the purpose-built circuit board I've used to add a fan and a real-time clock to the WaveShare board. That's the couple of daughter boards that sit on it to offer real-time clock and fan control. And that's a similar board for the Pi Foundation I/O board, so that it offers the same two daughter boards plus a capacitor and resistor to offer a dual-purpose button which will reset the computer and choose operating system. If you hold it down after resetting, it will go into Linux. If you just press it momentarily, it will go into RISC-OS. I've also found a real-time clock board for the Desktop Mini. The reason for buying it unsoldered is that you have to put the socket on backwards so that it fits in the right direction. That's the alternative, a purpose-built circuit board with a standard real-time clock on it that has been turned around through 180 degrees with a very simple little circuit board. So, what do you need to add? Well, it's a mixture of real-time clock, boot switch and fan control board, depending on which board you buy. The simplest solution is the DeskPi PyroCube. It's easy to fit an NVMe drive. You can put a purpose-built PCB on the back, or you can buy a suitable device from eBay. All the sockets are on one side. So there's a do-it-yourself, that's the wave share board in a polycarbonate case. And that's the rather larger high foundation IO board with a SATA interface. So I've done that rather quicker than I thought. If anyone's got any questions, I'll be happy to answer them. And you're welcome to take away a set of the notes with the gritty detail in them. But it's rather good news that NVMe filing systems has been released for RISC OS at this show, so that's quite a step forward. Far away.
So we've waited ages for one NVMe file system to come along, and two have arrived at once as per normal. I know you've tested both of them. I wonder what your views on the two different systems were.
It's a little tricky because
tell us all the dirt.
It's like saying halfway through a horse race, right? You've seen how the horses are running. Which one do you think is going to win, right? Because they're both still being developed and they're both still being optimised. So you're asking me to comment about two moving targets and where they're going to be in 3 or 4 weeks' time. It's almost impossible. There are simple things that need to be sorted out, both of them, that are relatively easy to sort out, but they all take a few weeks of iterating. They're both similar. I'll go back to this slide here. Their speeds are similar, so there isn't much to choose between them on speed, but then neither is that terribly relevant because they haven't finished optimising both of them, so we don't know where they'll be when they finish that. When the Ionics was released, the DMA on the hard drive was suppressed because it didn't work, but when it was then released, the speed picked up, so it's very difficult to answer that one. But I think it's not really, I can't really say much more than that. Looking between the two, you can't really sort of say. One thing I would say though is that the NVMe FS is being released as free software in open source, and the RComp version is also going to be released as free source. And although they both use different cores at the moment, that is going to be harmonised so that they'll be interchangeable. So I don't think that's a problem. Right, any more questions?
One of the
Righty-ho.
when you said you tweaked the partition table, your small program, were you
Yes.
simply just changing the ID numbers?
What I did was, I wasn't going to do anything to start with, but I realised that because they were, when the RISC OS 2 partition is done, it populates partitions 1 and 4 and leaves 2 and 3 unused, and that's fine, nothing worries about that. But if you then add a partition in Linux, it slots it into the first available spot, which is 2. So you end up with them on the disk in the wrong order. Now, the partition table is a 512 byte block, but this bit of it is just 4 16-byte sector start here, sector end there, and this is partition 1, sector start there, this is partition 2. So all I did was to swap them around so that I put them in the order in which they're on the disk, so that the RISC OS file core partition became 2, and the 2 ones I'd added on Linux, 2 and 3, became 3 and 4, and Linux was then happy. So it was just a small basic program to load the partition table and read each of the 4 partitions, then put them back on different order, and then write it back again, and then very carefully reboot Linux before it has time to get confused with the changed partition table, and to start up again, and then it was fine. So yes, it's because, for reasons which I don't understand, RISC-OS uses partitions 1 and 4 for its dual partition solution. RISC-OS itself doesn't look at a partition table. It knows where a filing system sits on the disk, and it just uses it. When you put the 2 partition on using system disk, it creates a partition table so that other operating systems know which bits are reserved to RISC-OS. And if there are no more questions, on hold. Thank you very much.